Hey folks. All right, well, we had done a couple of review sessions on structures, and there were a couple of requests to get into a slightly deeper example with arrays of structs and structs of structs. So I just want to kind of run through a quick example here and give folks a bit of a look at this. So let me navigate my way around my too many open windows here. And so what we're going to do here is we're going to come up with a little program where we've got two layers of structs and an array of those. So we're going to represent a bunch of snow people, snowies. So each snowy is going to be represented by three circles, right? One for the head, one for the body, one for the legs. And so we're going to have a struct for a circle. Then we're going to have a struct for one of our snowies that has three fields. Each of those are a circle. And then we'll create an array of these snowies. And we'll just look at we'll look at definitions for the structs. We'll look at how we can dynamically allocate the array and deallocate it later. We can look at using a loop in our main routine, for instance, to go through and fill all the information about the snow people. And we'll look at just simply calling a function that fills the entire array for us. So you get a bit of a look at a few different approaches to doing this. So the idea is, again, what this program is going to do is it's going to have two structs, one kind of struct to describe a circle. So that's just going to be its radius and its XY coordinates. Another kind of struct to describe a snowy. So that'll have a circle for the head, a circle for the body, and a circle for the legs. And we'll provide a few different functions. One function where you just give it a circle and it will fill it or print it. One function where you give it a snowy and it'll fill and print the three circles for that snow person, but calling the function that we did for circles, right? So it doesn't have to rewrite a whole bunch of that code. And then we'll look at having routines to go through and fill and print an entire array of snowies. So just essentially each element of the array is one snowy, and we'll just call that fill print snowy routine to deal with them. Then in the main routine, we'll dynamically allocate a whole array of snowies. We'll go through one example, one loop where we go through and call, fill snowy, print snowy, and a second example where we just call the functions that fill an entire array and print an entire array. And then we'll delete the beast at the end. So that's the plan, just to show some example syntax and a little bit of the logic behind this. So again, we'll have a struct to represent an individual circle. So that's just got the coordinates for the center and then the radius. All three of them are floats. And again, I just combine them all into one line here, right? You're okay to define structs like that, or fields like that. And then a second struct for a snowy, right? So it'll have one circle for the head, one circle for the body, one circle for the legs. And again, it's pretty normal to sort of structure your data hierarchically like that, right? Define one of the individual components and then define your thing as a whole that uses those individual components. So in terms of our functions, we'll have one to fill a circle, right, where you pass it a circle, pass by reference so that we can alter the fields, and we'll just ask for the x and y coordinates and the radius and read them in. And again, ordinarily we'd be doing error checking here, but just to avoid convoluting the code too much, again, we'll just go through and say, okay, for the circle that you passed me, we'll just fill in the x field, the y field, and the radius. And similarly for a print, in this case, it doesn't need to be passed by reference since we're not changing anything. We're just going to print out that circle's x and y and radius fields. So no big surprises there. So our fill snowy, our print snowy, will take a snowy passed by reference. So one of the structs to represent an entire snow person. And again, for this one, it's going to have three fields: head, body, and legs. And so we'll call that fill circle to get the head, fill circle for the body, and fill circle for the legs. And again, since it's passed by reference, it's going to go in and fill in the data for our head, body, and legs fields. So you can get this sort of hierarchy where at each layer, you're just saying, okay, at the layer of filling a snow person, I don't want to worry about x and y and or you know s.head.x or s.head.y or s.head.radius. I'll simply call that fill circle routine I had and let it worry about the gory details. And that gets even more important when you're doing lots of error checking inside your fill circle. So gives us nice compartmentalized logic, easy to write, easy to see what's going on. And the same idea for a print, right? We're just going to call, let's say, let's print out the head and call that print circle routine for the head. Print out the body, print out the legs. And again, nice compartmentalized logic. Excuse me. All right. Then if somebody had an entire array of these things, I should probably have called that S, not C, an entire array of snowies, and they knew how many there were, then they could say, well, could you please fill all of them? And so I just have a loop that says, okay, well, each element of the array is going to be one snowy. So for each element of the array, I'll say, well, fill in this element, and I'll pass it, you know, the ith element of the array, and then that fill snow will go off and fill in the information for that individual snowy. Same idea for print all, right? We'll just go through and say, here's my array of snowies. Each element is one snowy. Here's how many there are. Please go through and for each of them, display the information for that one snowy, right? So again, each element is one snowy. So that's going to call print snow, which is going to go off and call print circ on its head and print circ on its body and print circ on its legs, right? Which is going to go off and print the X and Y and radius fields for that particular circle. So it's nice kind of hierarchical logic, easy to work with, easy to see what's going on. So for our main routine, we'll just go through and say, okay, I'm going to create an array of these things. So I'll ask the user how many they have, and we'll allocate an array and then go through and fill it in and print it in a couple of different ways. So how many do you have? Again, we would error check, but I'm just going to grab it for now and say, okay, here's my pointer for my array of snowies. I'll try and allocate it. So I want an array of this many new snowies and store the address in my pointer. And again, we should actually stick in a no throw there, but we'll worry about that another day. If we actually have a valid array, if we allocated successfully, then I'm going to go through two approaches. The first approach, we're just going to use a for loop directly from the main routine and call fill snow on each element of the array. So say for each of those, you know, say they had 10, for each of those 10 snowies, pass it the 10th element or the ith element of the array directly to fill snow and say, okay, you fill in this snowy for me. So I can work directly from the main routine saying, here, go fill in this one element for me. And the same idea for print. I can say for each element of the array, go through and call print snow to print that one element, right? So I just pass it that element. So this is perfectly valid. But as you know, we also went through and created those fill all and print all that would take an array and how many, and it would do this for us, right? Which had similar logic in it, almost an identical loop inside. So we could simply call just fill all and pass it the array and the number. Call print all, pass it the array and the number. And once we're done with that, we can go through and delete our array. So hopefully this actually works. And let's give this a try. How many snowies? It's going to be a lot of typing if I have a whole bunch of them, so I'm just going to go with 2. So in theory, at this point, it's successfully allocated an array of 2 snowies, and it's going through that manual loop first to say, okay, please go, you know, fill in each of the elements. So this is for the first snowy, supply data for the head, so it's going to ask for the x coordinate, y coordinate, and radius. I'm just going to kind of type ahead here and enter 1 for each of them. And then for the body, again, the x and y coordinates and the radius for the body. So, and then same thing for the legs. And so we've got our first snowy's data entered, and now we're on to our second snowy. And again, we'll just do the same sort of thing. So theoretically, we've got the information on our 2 snowies, and hopefully it's going to print them out. And yeah, we get the information. So that for loop that was doing the prints for us is going through and printing the information on the first one, the information on the second one. And again, the idea is to print a snowy, it's going through and printing the head information, the body information, and the leg information, and it's calling the print circle routines to do that. So that got us through the manual versions. Now we're just diving into the second cycle where we were going through and calling that fill all and print all. And again, we can do the same sort of thing. I'm just going to use the same data again, and hopefully we get, hopefully we get the same sort of idea. And yeah, things seem to be working out okay. So that is very much the idea, is take this kind of hierarchical approach. Have a struct for your basic component, a struct for the container for those to build up something bigger. You can have an array of those. And if you provide appropriate functions to deal with each of the different layers, each of the different kinds of struct, relying on the ones for the more primitive structs, then you can build up quite straightforward logic to work with very complex components. All right, I will leave that one there for now.